Hello, everybody. Now, what we're going to do is we are going to handle something that we lovingly refer to in the calculus world as implicit differentiation. What that means, I'll wrap back around to it in a second. But let's look at something here very basic. Find dy over dx if y equals 3x squared. So we know this so far as just taking the derivative. So yeah, most of you say, oh, well, that just equals 6x. And I'd be like, yeah, that's great. You took the derivative of 3x squared and got 6x. However, what you're really doing is you're taking the derivative of a y equation with respect to x. That's what all the terminology here with the dy and dx means. And what we haven't talked about is how we write the notation on the left-hand side. And on the left-hand side, the y would turn into dy over dx. Because the derivative of 1y turns into 1 dy over dx. Now, the reason why we have the dx, because that is the variable that which everything is gravitating around in this particular question. And why the reason why we have the dy is because literally we took the derivative of a y expression. So that's some of the semantics. But looking at this is my final answer. You're looking at this, you're like, okay, I really didn't learn anything new. I'm like, I know. It's, I just kind of explained some of the theory behind it. But let's make you learn something a little bit new. Sometimes our equations have multiple variables, just like those magical words say right there. But we could still find dy over dx. So that's overall what I am looking to do. Let's find dy over dx. So let's take the derivative of this equation. Now, the derivative of x squared turns into 2x. No big deal. Now, the derivative of y cubed would turn into 3y squared. However, we're not done. Normal power rule here, the 3 goes in front, subtract 1, that's where the 3y squared. However, since this is not the variable for which I'm taking the derivative with respect to the derivative, hold on, let me restart that sentence there. The y is not the variable for which I am taking the derivative with respect to. That's right, that's what I'm trying to say. In other words, I'm trying to take it with respect to x. So what I have to do is throw a dy over dx here whenever you take the derivative of a y piece to let you know, hey, this is implicit differentiation, and that everything else is done with respect to x, but this is a y piece. Continuing, the derivative of 3x becomes 3, and the derivative of minus 5 goes to 0. All right, so we didn't finish, but I just want to recap what I just did. X squared turned into 2x. Y cubed is 3y squared, then a dy dx. 3x is 3. All right, now I want to finish. We want to solve for dy over dx. In other words, over here in the previous page, he was all by him lonesome. That's the answer. That's what we want. He's not alone. He's got things with him, and we need to move those things away. So the first thing I would recommend you do is move over stuff that's not attached to the dy dx. So I have 3y squared dy over dx equal to 3 minus 2x. Then divide by the 3y squared. So then my answer is dy over dx is going to equal 3 minus 2x over 3y squared. You do not need to simplify that. There are no negative exponents, and there's not a complex fraction, which we're going to see plenty of in this little unit. So we be good. This is our answer. What does this represent? Well, we have an equation over here, this guy, that's an equation. And if I wanted to find a slope at a particular point, as long as I know the x and the y value, you could plug them in and get the slope. That's one of the interpretations. That's what we refer to sometimes as the geometric interpretation. But I digress. Bam, let's try another one. We're just playing around with the algebra aspect of the calc. All right. So find dy dx if you have 3x squared y plus 2x equals 7. So let's look at those bits. Oh man, look at this first bit. I believe we call that the product rule. Dun, dun, dun. All right, you could be annoyed. That's fine, but we have to do it. Now, it's a product, and some people might say, oh, but there's three pieces to the product. You got the 3, the x squared, and the y. Well, in order to simplify my life, I'm going to lump together the 3y squared. So I'm going to put him together. So I'll do my product rule for that part first. So I have 3y squared, then the derivative of y is dy over dx. Because like the derivative of x would just be 1, the derivative of y would be 1, and then the dy dx. Plus, we have 6xy plus 2 equals 0. So a little discussion here. The 6x came from the 2 times the 3x. That's where the 6x comes from. Remember, with the product rule, it's the derivative of one with the other, and then the other way around. So here, I didn't take the derivative of 3x squared. I took the derivative of y. Bam, that's what you get. Plus, then you take the derivative of 3x squared. Bang, that's what you get, 6x. Then you don't do anything to the y. Since I did not do anything to the y, I do not need to put a dy dx there. Them's the rules. Then the derivative of 2x just became 2. The derivative of 7 becomes 0. But wait, there's more. We have to get dy dx by itself. All right, so you're going to start off by subtracting these two guys onto the other side. So you're going to get 3x squared dy dx equals negative 6xy minus 2. Then divide by the 3x squared. And then, my friends, nothing else simplifies. This is our answer. That's all, folks. Well, that's not all, folks, for the video. But wait, there's more. Here's another one. Okay, so I see a product rule with trig. Great googly moogly. Oh, I finally have the y piece here, and then the 3x over there. Okay, all right, so let's start off with that little product rule going on right there. So I have 4x squared cosine x plus 8x sine x minus, that's the product rule done. Now I'm up to the derivative of the 4y squared. So that would be 8y, and then a dy dx equals 3. And, okay, so this piece and that piece, they're going to move on over. So I have negative 8y dy dx equals 3 minus 4x squared cosine x minus 8x sine x. And then listen to me. Divide by the negative 8y. All right. Let's see. I'm going to make this all look pretty. So dy dx. Well, that negative sign can just get hoisted out in front of the whole darn thing. That's good. There you go. Whoop. Bam. Let's move on. Okay. If you want to take a stab at this, see how it works out, don't quit on the video yet because it's going to get ugly. If you know anything about me, I'm pretty ugly. Moving on. Okay. Bring that guy onto the other side. Okay. Divide by the negative 24y cubed. And just to simplify things, I'm going to drag that negative sign in front of the whole thing. He's not just in front of the 14. He's in front of the whole fraction. Oops. There we go. By the way, just for giggles, you could have also done this. I don't know if you're aware of this. if the negative sign actually distributed to the top when you divided it over, it just switches the two pieces as long as there's subtraction between them. Okay, let's kick it up a notch. Oh yeah, because I got multiple y's in this guy. So this is fun. Take the derivative of y the fourth first. So you get 4y cubed. And then we need a dy dx because it's implicit differentiation. And you did a derivative of a y piece. Okay, that's good. Then let's bring that minus there. Let's deal, because we have a product rule here. So just for simplicity's sake, pull the minus sign aside. That's how I like to deal with it when I see that. And then I'll do the product rule inside these parentheses. So it's going to be x squared times 2y dy dx. We'll deal with that. We'll organize those terms in a minute. Plus 2xy squared. All right, and then plus 5 equals 0. Okay. What do we got going on here? All right, let's group some things together. 4y cubed dy over dx minus. Now, when I fix that, it's going to be 2x squared y dy dx minus 2xy squared plus 5 equals 0. Now, getting dy dx by itself, first of all, it's going to require you to bring these two chunks onto the other side. Those two guys are going to be on the other side. So we're going to have 4y cubed dy dx minus 2x squared y dy dx. And when you move those other two pieces over, it's going to become 2xy squared minus 5. Bring those guys onto the other side. I'm going to scroll down a little bit just so I can work a little bit more here. Mixing my page just a little bit too. All right, leave the last two lines there. Now, in order to get dy dx by itself, what you'll end up doing, and I'll show you this once in slow motion. In the future, you can just quickly divide this on over, but you'd be factoring out the dy dx. And when you do that, you have these two guys together in, oh, I keep making that mistake. All right, I fixed it. So that you have their coefficients kind of together in their own set of parentheses, and then you can just divide that on over. So that you have dy dx equals 2xy squared minus 5 over 4y cubed minus 2x squared y. No complex fractions, no negative exponents. We good. Okay, let's look at the last one. Yes! All right, so we have so much going on with this one. All righty, let's strap on our helmets, because what we got here? We got trig, we got product, we got chain rule going on. All right. First of all, the 6 is the coefficient of the secant, so we're not going to do anything with that. The secant is the outside part of this piece right here. The derivative of secant is secant tangent. So you start off by going 6 secant, and by chain rule, 3x squared y to the fourth, and then tangent, 3x squared y to the fourth. Then we need the derivative of the 3x squared y to the fourth. All right, now that's a product rule too. So 3x squared times 4y cubed dy dx. Finally, the implicit, because we finally took the derivative of the y piece, plus, oh boy, 6x times y to the fourth. All right, plus 56x to the sixth, and I ran out of room, equals 42. Equals 42, meaning of life. All right, there we are. Good. This doesn't look like anything. It's supposed to be a y. All righty. Now let's see. What are we going to do? What are we going to do? What are we going to do? All right. Now you see, like, you have this stuff here in the parentheses with the product rule with that plus sign. The easiest thing to do is to take this bit and to distribute that to both pieces. But actually, before I do that, I'm just going to take a brief second and clean that up. I'm also going to move that 56 on the 56x to the 6th onto the other side too, to kind of clean things up here a little bit. So it starts off, I've got 6 and then the secant 3x squared y to the 4, and then the tangent 3x squared y to the 4th. I'm just doing some algebra at this point, just cleaning stuff up. Now 3 times 4, you need to take out your calculator. Here's the dx. All right, now that's going to equal, now since I'm subtracting this over, I'll leave the 42 in front. Okay. Alrighty. Let's distribute this whole chunk. That's, you're not following me, it's this whole chunk. I'm going to distribute to both parts there. It's going to get ugly, but you're going to be fine. Well, I don't know if you're going to be fine. I'm going to be fine. What's 6 times 12? 72? Thanks. Then you have the x squared, y cubed. And then you have, you know what, guys? I don't like doing this normally, but just, I know what's going to, that little squiggle that I just kind of put in there. That's a 3x squared y to the 4th. I'm just getting lazy. Don't tell anybody. There's the dy over dx. My computer's being annoying now. All right. So plus, now let's do the second distribution, the 6xy to the 4th. Oh, by the way, yeah, you put the dy dx at the back end of your, when you have organizing your terms. Dy dx just goes to the back. That's just the order of it all. 6 times 6 is 36. And then we have xy to the 4th. And then we're going to have secant of yuck again, tangent of yuck again. And then on the other side, yeah, you see how calculus is fun? Look how big this question's getting. And this is nothing. So for all you guys and girls taking calculus next year, just remember, this is going to get good. All right. Now you see the dy dx term? I'm going to highlight him here real quick. I use red. Why? Because I haven't used red in a while. There's the dy dx term. That's that guy. Now, that means that this guy, this piece, is going to have to move on to the other side of the equation. That this other piece is going to have to move over. You would subtract it over. So he's there. He remains the same. And again, I'm going to cheat at it a little bit here. And I still have the dy dx. Look at my little computer's falling apart. It's like running slow and slow. All right, I need some more space. And that equaled 36. Oh, I forgot what it was already. X, y the 4th. Yeah. Then the secant of goodness and the tangent of goodness. And then we had, let's see, we subtracted that over. Oh, great googly moogly. So I needed to make that negative. And then we have plus 42 minus 56x to the 6th. Wow. Okay. Here's the coup de grace. So now you're going to take this stuff. Let me highlight the stuff I'm referring to. Let's go for a darker red. That's good. That's all this stuff right here. That's the coefficient of the dy dx. So that's the part you're going to divide on over to the other side. All right. Now, when you're done, that means you're going to have dy dx equals. This is your numerator. I've been using these little symbols. I forget what they represent in each one. Oh, 3x squared y to the fourth. Okay. Plus 46 minus 56 x to the sixth on top of 72 x squared y to the third secant okay. That was a lot. That was like heavy duty stuff there. That last one, if you stuck with it, watch it over again. I'm not going to sugarcoat this in any way, shape, or form. This is not the hardest question you're going to see. So, yep. Yeah, good stuff. Good stuff. We'll talk later. Stay out of jail. Oh, yeah. T out.